We are pleased to introduce William W. Schirkenbach as our Distinguished Leader Forum speaker. For the past 15 years, Mr. Schirkenbach has worked to have Dr. W. Edwards Deming, a well-known and respected management consultant on quality, be recognized for turning America around, not just Japan. In 1982, at the recommendation of Dr. Deming, Mr. Schirkenbach joined Ford Motor Company as its Director of Statistical Methods. He was responsible for guiding the implementation of Dr. Deming's philosophies, including statistical management methods throughout the company worldwide. Based on his successes at Ford, he is now helping General Motors implement the Deming philosophy. He took on the assignment of BOC Group Director of Statistical and Process Improvement Methods in November of 1987. He is the author of the book, The Deming Route to Quality and Productivity, Roadmaps and Roadblocks. He also has written numerous articles and papers on the subject of quality, and his work has been included in 6 recent books.
I want to point out that I think this is going to be perhaps the longest 2 hours you've ever spent in your life. Or at least it's going to seem a lot more than 2 hours. And I'm going to take complete credit for that because by trade, as Kurt had mentioned, I'm a statistician. And as you know, statisticians have absolutely no sense of humor whatsoever. If you've ever had the privilege of sleeping through statistics classes and math classes in the university. But I guess on the positive side, we do get along well with top management because they don't either have a sense of humor. So we see eye to eye on at least a few things. It's a good chance to speak with the leaders of Exxon. I had a chance to speak earlier today with some other people, senior management group as well. In Exxon, and I think we had a very good session. The purpose of that session was mostly to try to talk philosophy and to try to open up perspectives from their point of view. What I'm going to try to do with you is also talk a bit about philosophy, but get more into the hows we're going to do something. I mean, if anyone asks you if you were for quality, you'd absolutely have to be insane to say, no, I'm not. So everyone's for it, but not many people know what it is. Not too many folks are against it anyway. But you got to know what to do. That's one of the most frequently asked questions by top management of me. And that is, okay, I buy the premise, I'm for quality. What do you want me to do? And so I'm going to talk a bit about that right now. What I'm going to do, as I did with the group this morning, is share with you a videotape that Don Peterson, the Chief Executive Officer for Ford Motor Company, did a few months ago. And that it's a brief 16-minute videotape, but it's going to give you an understanding of how he felt about his relationship with Dr. Deming. First of all, before we proceed, how many people have heard about Dr. Deming or feel they understand what Dr. Deming is? Okay. Well, that about half and half, something like that, maybe a little over half. Okay, we'll hopefully, and I think we'll get into that in a little bit more detail so that those of you who have heard about Dr. Deming can understand it a little bit better, and those of you who haven't heard of Dr. Deming can get back to work. What really is meant by continuous improvement, what is meant by how you get continuous improvement, customer satisfaction. I think there can be a one sentence or one phrase summary of really a new way to manage, something that every manager should understand, and that is that, and it's captured by the statement, I don't know if we're going to be able to see this, but it's captured by the statement, very simple statement, pride of ownership through pride of workmanship. Now, you're going to have to, I'm going to explain what I mean by there because things are not as they seem. Obviously, that pride appeals to emotion, not necessarily logic. But certainly emotion. and that has a lot to do with it. So I'm going to spend the first few minutes, more than the first few minutes, looking at pride of ownership. And I think you need to understand that pride of ownership through understanding a process model, recognizing that every one of us in this room, every one of us in this world, everything we do is a blending of these 5 generic inputs: people, materials, methods, machines, and environment, blending together to produce an outcome. Hopefully what we do with those materials or people or machines or equipment or within an environment is add value to those and pass it on to another customer. All of us are customers to someone else, and all of us are suppliers to another process manager. We've got an interdependent network, if you will, of customers and suppliers. You've all got the ultimate customer to satisfy or to be able to take pride in his work, or pride in owning, but we all have intermediate customers and suppliers, and that really is the key to understanding business. Now, one of the common misunderstandings is we try to blend these people, materials, methods, machines, and environment is that we typically say if only the people would follow the instructions that we gave them, use the machinery as we intended it, follow the procedures, use the training we gave them, and within the environment that we gave them, that everything would turn out exactly as we had planned. Well, in fact, we know this is this world. And in spite of all of the care we take to try to manage those resources and control them, if you will, there's going to be variability once this process begins to operate. There's going to be a variability, distribution of outcomes. Now, some processes are people dominant, some are, this is another way of looking at that with a fishbone diagram. Some processes are people dominant, others are material dominant. Some it's rather amorphous. Now, when you look at the contribution, this is the end variability that any customer sees. The material contributes variability. The equipment may contribute variability. People may contribute variability. Method, environment, they all blend together with their own sources of variability. And that blending manifests itself in the distribution or variability that you see in the outcomes, or at least the outcomes that you're concerned about. One of the bigger misunderstandings of management is the thought that the people contribute a lot to the variability of a process, when in fact, if you look at any segment of a process and a great stream of processes, the people very rarely contribute a lot to the variability of that process. It's usually upstream variables that contribute to any of the variability you may see at one particular segment. Who selected the people to begin with? Who selected the contractor? Who provided them the training and the education? Are they using the materials, the equipment that you gave them, the procedures or methods that may be flawed? And yet we search in our zeal to look for accountability, finding out who's responsible for that particular process, and because you're going to reward them or you're going to penalize them, many times we don't recognize that this end result is the combination of blending people and materials and methods and machines and environment. And we too often mistakenly focus on the people as a root cause, if you will. Now, what I'm going to do, I had mentioned a little earlier that obviously every one of us is a producer, every one of us is a supplier, a customer. A lot of folks you may have heard of SPC. You might think it's statistical process control, but it really isn't, a supplier, producer, customer. So you need to think of it in that perspective, and it's not really a tool. What I'm going to do is try to gradually make this model more complex, as we all tend to do things, take a simple business and make it extremely complex. And I'm going to focus on the fact that there are two sources of feedback typically in this process model, one from the customer and one from the process itself. Now, before I get into that in detail, we need to understand that the way everyone, or by everyone I mean most of us, the way most of us have managed our processes in days gone or previous to this is by looking at the process as purely a feed-forward kind of a system. And by that, obviously, I mean that we would make whatever it is, we would blend the resources and make whatever it is we were supposed to make. And then the method we would use is one of trying to mass inspect, or you would make it and you would inspect it and then pass the supposedly good product on to the customer. And because we had to run a business, you had another check on the supposedly bad product to see if you could rework any of that stuff or reblend it or whatever to put it into the product stream. And that's what those that you absolutely could not rework or reblend, you had to scrap it. You somehow had to take a loss on it. And this was a very commonly accepted and very prudent way to run a business. In the commercials, they don't say Haynes until I say they say Haynes, dependent on inspection. Or you got that lady in Honda saying that Clara's gonna say ship it. It ain't a Honda until she says it is. The public has been led to believe that inspection is a prudent way to get quality, when in fact the quality and the cost that you put into it is already baked in, and all you're doing is separating good from bad. High-cost way to do business, and yet it's as proliferated in many aspects of virtually every business. Feed forward. You can get good quality, but your customer has got to be willing to pay for it. And what we're finding right now is that a lot of customers aren't willing to pay exorbitant prices for good quality, because some folks have figured out a way how to get higher quality at a lower cost. This is high quality at high cost by trying to detect defects. I don't know, this seems like a pretty astute group, but I'm gonna try it anyway. It worked this morning. I'm going to ask you, if you haven't processed this material before, or if you have, then don't participate. But I'm going to ask you to read that sentence. And I've got a pretty persnickety customer, and that customer wants to know how many times the letter F is in that sentence. I want you to read the sentence, count the number of times you see the letter F, keep it to yourself, and then we'll see what we get. Everyone understand what the letter F is? We're going to look pretty astute, but you can't tell all the time. Anyone need any more time with this? Because I got a production quota to meet. Anyone need any more time? Read the sentence? No one said yes, I need more time, so I'm going to pull it off. Okay. As I said in the beginning, I'm a statistician and hardly have any sense of humor at all, but this is a true story that you may get a kick out of. How many of you saw exactly 0 Fs? And no one did. We used to give this test on run this process with this material, but the material we used or the medium we used to give the people the material was a sheet of paper. And we used to do this until we had Xerox machine problems one time, and several folks in the audience got a blank piece of paper and they saw 0 Fs. I didn't ask that before we had that glitch, but I got to ask it now every time. We're going to check the honesty here as well. How many saw exactly 1 F? See what the peer pressure is. How many saw exactly 2 Fs? Anyone see 2 Fs? How many saw exactly 3 Fs? Okay, you got some honest folk. Okay. How many saw exactly 4 Fs? Okay, 10. How many saw exactly 5 Fs? Everyone understand what the letter F was? I got 3, 4, 5. How many saw 6 Fs? Okay. How many saw exactly 7 Fs? Anyone see 7? Anyone see more than 7? Okay, no one was out partying last night, I don't think. So let's look at this. Well, first, I want to make a couple points. First point is teaching adults is a lot more difficult than teaching children. And that's primarily because each of you bring with you into a learning situation your absolute knowledge of how the world behaves. Each of you brought with you your absolute knowledge of how to read. And most of you, and this experiment has worked, whether English is a second language or first or even third language, most of you learned to read phonetically, at least in this age group you did. And those of you who saw 3 Fs, the method you used to process this material was more than likely one of reading the passage. And when you read it, you saw the F in finished and files, and you saw the F in scientific. But what you didn't see, because you read it, were the Fs in the 3 ofs, because when you read the sentence of sounds like a V, it didn't register, and you had a production quota or whatever, and so you saw 3 Fs. Obviously, those of you who saw 6 Fs, there also is an explanation, and you may have processed, the method you used to process the material was different. You may have focused on every letter, or you may have started to read backwards. Proofreading might be your profession. I don't know. Some managers, that's about all it is. In which case, you used a different method to process the material. You came up with a different answer. You saw 6. And there's a good explanation for that. Those of you who didn't see 3 or 6, there really is no scientific explanation. But all I can say is that every company needs a few of you folks around to try and keep it interesting. I want to address the carefully taught thing before I go into the second reason, or the second point I wanted to make here, and that is because each of you came in here very carefully taught, and you knew how to read. I'd ask you to try and keep an open mind, because each of you bring with you an exact knowledge of your experience and years of practice in managing, and you've got a worldview on exactly what a good manager should do. Unfortunately, that paradigm or that perspective has been developed under a period of what Bill Ouchi calls superstitious learning. If you think back after World War II, and you looked at heavy industry, and the petroleum industry was certainly qualify under that, it didn't exist anywhere but in North America. The rest of the world's capacity was leveled. And so in that, so you had an environment, a virtual monopoly. Certainly everyone was playing by the same rules, old boys or whatever. And if you also look what was happening after World War II, you look when Peter Drucker began to write his books on management as a profession or as a science. Management was making a transition from management as a right because you own the place to management as a profession or a science, and you get a lot of proliferation of literature trying to make it seem so anyway, less of an art than a science or a right than a science. And under those conditions, management carefully learned what it took to increase profits and increase markets and do all the good things that businessmen do. And yet, under that environment, we could have used any system, and profits would have increased and business would have expanded. And yet we carefully learned, that superstitious learning, carefully learned that was the right way to do something. Well, Deming says that we are in a new economic age, and the systems that got us to this point of preeminence, and Exxon didn't get this big by doing a lot of bad things, they did a lot of right things, but they were systems that were right for their times, perhaps. And every system that we've got in place has to be examined, because those systems are not necessarily going to be the ones that are going to keep this great company in a point of preeminence. And you've got to recognize, as Peterson did, that we're working in a truly worldwide competitive environment. and it's not standing still. So the things that got you to where you are ain't going to be the ones that are going to get you beyond where you are now, at least not in the next few years. So you're going to have to keep an open mind, because a lot of what I'm going to say is going to challenge your perception of what you think a good manager should be doing. And so I ask you to keep that open mind. Second point I want to make is that 100% inspection or mass inspection isn't going to get you the quality that you think you're getting. Even if you have automatic equipment or laser ways to analyze the feed or whatever, it doesn't get you the quality that you think it's going to get. I couldn't have come up with a more simple defect, the letter F. Everyone understood what the letter F was, and yet out in the field or in the accounting office or whatever, the defects are going to be not as straightforward as those. There's going to be a lot of ambiguity, measurement error, whatever, a lot of fuzziness. You cannot, the quality that you get with the defect detection approach is not what you think it is, which leads people to say inspect on inspect on inspect, and that's also where you get the high cost in trying to get the quality. There's a better way to manage a process, and that better way is one through trying to prevent the defects from happening before they occur, and this is in the pure sense, feedback system. And obviously the way anyone operates a business is a blending of the feed forward and the feedback, the detection and prevention. But in the pure feedback system, we have these two sources of feedback, one from the customer and one from the process itself. This is a better way to manage a process, and it's better because it's cheaper in the long run when you look at total cost than it is to try and make something and then correct it. But I want to point out that there's a very big difference. The best you can do with the defect detection system or a defect prevention system is to get 0 defects. It's defect focused, 0 defects, and every one of you here would feel very happy if you got 0 defects. That means no warranty, there's no complaints, no need to reblend anything. You feel very happy. And when you look at every system that we've got in place, it's structured to feel very happy over a lack of a negative. No adverse variance to explain in a budget review. Nothing was late, whatever that means. Engineering drawings or deliveries, whatever, nothing was late. You'd all feel ecstatic that you had a lack of a negative. But a lack of a negative, 0 defects, no complaints, is a far cry in this economic age from having people brag about owning your product or service. There's a very big difference between a lack of a negative and a very strong positive. You can get into a meeting. You walk into a meeting and you try and get something done and there ain't no one complaining. You figure everything is great, just try and implement it. A lack of a negative does not mean a strong positive. And market research folks know from all sorts of work that what really sells something, internally or externally, is having a bunch of customers bragging about owning your product or service. If you're in finance and you're submitting reports, if you actually talk to your customer, are they bragging about it, or you feel happy that they're not complaining? They may have recognized that it's too hopeless, and they're reprocessing your reports to try and put it in an order that makes sense to them. They might be using 2 cells in that entire report that are useful or of value to them. The rest of it's waste. And many times we try to think that we know better than the customer of what adds value, we as experts in the subject matter. You need people bragging about owning your products or service, not just not complaining. And we'll get into that. What I'm going to do is focus on this area of the model. I'm going to focus on these two sources of feedback. I'm going to call them, if you will, the voice, instead of process feedback and customer feedback, I'm going to call them the voice of the process. That's one way of looking at it. And I'm going to blend with that the voice of the customer. And we'll put these things together, and we're just focusing on that area of the model. The job of any process manager, the job of every one of you in this room, every one of us in this room, is to manage our process such that the voice of the customer is coincident with the voice of the process, or vice versa. And you notice, in order to get them coincident, I had to move the voice of the customer. I can do that through advertising or education or acquainting the customer with what we've got to give. And I do that by moving the voice of the process, which is the results of blending the people, materials, methods, machines, and environment. You could look at it one way by saying that's the plan and that's the actual. Now, if you take a deterministic view of the world, or you're from finance, and that typically will be the case, or if you're from engineering, you got a deterministic view of the world. That was the plan, that was the actual. Explain to me the variance. There's a difference there. There's got to be an explanation for it. Well, again, that's not in this world. I know that happens, but it is not indicative of what actually happens in the world. You're going to get an explanation for that variance. Whether it means anything or not in the grand scheme of things is completely questionable. You get an explanation for why the stock market went up or down every day, and you can't really believe that it's that simple, that there was this mysterious cause that did that. In reality, the world is variable. And we know that, again, by some of the systems we put in place. For instance, the voice of the process, I haven't erased it from this morning, but the voice of the process, as we saw a little bit earlier, there's a distribution of outcomes. And when you see this Gaussian curve here, you've got to, I'm assuming that the process is in control, that is statistically stable, predictable. If you don't see a Gaussian curve, that means it's chaos and it's not predictable, and they send two different messages to you as a process manager. Now, if you look at the voice of the customer, this also is not deterministic, and if you look at the voice of the customer, there's variability there. So in actuality, this is what you're looking at, because all of these at one particular point in time, they're just estimates. Your best estimate, you put your customer hat on and you estimate what it is the customer really would want. You ask a different person, you get a different answer. You ask a different customer, you get a different answer. There's going to be a distribution of wants from the customer. There's going to be a distribution of results from the process. Which two are you going to compare? You think that this and this are cause for explanation? You're going to compare that plan with that actual, or how about that plan with that actual? You know over time that the numbers will be different. So you have to understand some statistical thinking if you're going to be an effective manager in today's world anyway. And by effective, I mean to be able to really compete with people who have a different worldview than you might have been brought up with. Now, if you look at our systems, many of the engineers and many of the accountants, many of the managers have recognized that there is variability, and the way we've portrayed that voice of the customer is you got specification limits. We recognize that, well, as long as you get it within this band, everything's going to be all right. You go outside of that band and we got a problem. Okay, you've got an exception and you've got to explain that. I guess if you're from manufacturing, you can recognize the comparison of the voice of the customer with the voice of the process is really the capability of the process. As long as the outcomes are within the spec limits, it's capable. One of the problems, the misunderstanding is that the voice of the customer gives you a completely distinctly different perspective than does the voice of the process. For instance, here you have no problems. And here, now that you've got something out of spec, you've got a problem. Obviously you do, because some of them are outside of that acceptable range. So you mobilize the resources, and the instructions to your people are find out what's different between those parts there and these parts here. Absolutely a guarantee that you're going to increase your costs. Because if you don't understand and listen to the voice of the process, and you don't realize that the same system that generated those parts there generated these outcomes here, you're going to be ending up spending a lot of money. Because people are going to, the study of defects, Dr. Deming says many, many times, you might as well study the good ones. The same, it makes just as much sense. And yet our perspective is we're going to find out what's wrong or different between that part and that part. You ain't going to be able to with conventional methods. Because the blending of the resources which you control dictate those outcomes. If it were out of control, for instance, if you had a distribution here like that and you had some parts that were outside of that system, that predictable system, then those are indication of special causes. And in fact, you could come up with a reason by conventional methods of using your subject matter knowledge to try and come up with a reason why they were different. In that case, very definitely you'd be able to. But just if the voice of the process says you're stable, predictable, you have to use different methods to understand the contributions of variability that the various incoming elements make. And that's something that's very rarely done. What we typically see is we use that voice of the customer as an indication of something special, and we take action. We adjust, reblend the resources based on what we find. We think this is a special cause, and we end up reblending, changing the people, materials, methods, machines, or environment. And what happens when we do that is we can typically over-control the process. Now, one of the manifestations of over-control, I'll give you an example of it, of trying to reblend the people, materials, methods, machines, and environment inappropriately. Here's and forgive, this is a manufacturing example. And this was done at a transmission plant in Bordeaux, France. And it was a 50-piece sample, and these are the spec limits. Automatic compensating equipment. We'd paid a lot of good money to buy this microprocessor-based equipment. And it was programmed, and you folks in this industry are very attuned to automatic compensation and process control, automated process control, not statistical process control, but automated process control. And that is that if it were off nominal this far, it would adjust the other way equally that far, but the equal and opposite direction. A lot of the microprocessor-based equipment are based on that algorithm. And some of it isn't. Some of it use an average, and some of them compensate X% based on what you get. But you end up over time with the same results by any of those. What you see is that in a 50-piece run, you essentially had virtually everything within spec. And if you understand, if you're looking at the world from the view of as long as you're within spec, everything is fine, that seems fine. The money was well spent. Well, we asked the people to run another 50 pieces, but turn off the compensating device. Again, they had just spent a lot of money on this new machinery, very proud of the fact that they're keeping it within spec. So they turned off the device, didn't compensate, just let the process run, and ran 50 more pieces. That's what they saw. And again, you may snicker, but I think there's not one of you in this room who wouldn't say to your boss that it was in virtually anything you do, that if only you get me the new equipment, whether it's a new computer or measuring device or a few more auditors or whatever, or manufacturing equipment, that you couldn't get in better quality. Got the state-of-the-art stuff out there. What we forget is that the outcomes are a result of a blending of people, materials, methods, machines, and environment. And some are equipment dominant, others are people dominant, as I said, but many, many, many times we find that you can get great savings if you re-look at the methods by which you're programming this stuff, or by which you're training your people to say you react to this or react to that. Keep the stuff within spec. There are economical ways to do it, and there are brute force ways to do it. And if you're over controlling reacting to individual signal and not to statistical signal, you can double the costs, even though everything is within spec. You can literally double your costs and you won't recognize it. So, and you don't just have to focus in on manufacturing. Every time you as a manager hold a meeting and demand to know why costs went up 1/10 over last month or last quarter, or why did sales go down or throughput go down or whatever it is, and you send your people scurrying out trying to come up with reasons why and take action adjusting this and adjusting that, you're guilty of over control. And the higher up you go in the company, the more damaging that can be. So you have to understand that there are better ways to manage the variability, the reality of variability that we see in this world. Now, you can also make the extension, and I can talk about the fact that this also applies to the setting of goals, you could say. You could have and the way we evaluate folks. You can have a situation here where the goal might be to get a 40% increase in profits next year. Okay, that's the goal. So that's 40. I think I wrote on this piece of paper. That's 40. And the voice of the process comes in. That's your druther. You put your management hat on, and it can be a wild guess. You could have thrown a dart at a dartboard, or you could have done your market research and know that you'll be out of business unless you can get 40% more profitability so you can reinvest it somewhere. Not the issue. You as a manager, once you've said that's what it's got to be or should be, have an obligation to see how it's been. The blending of people, materials, methods, machines, and environment. And if it came in that this was the actual, and if the data showed that we're in control, it might not, you're going to see that some folks made 40% improvement in profits, some folks made 50%, and some folks made 60%. What you as a and some folks, by the other hand, lost money. Okay? What you as a manager have to recognize is that as you manage that system, you're in it for the long term. That if the system shows you've got if the data show you have a stable system, then the same system that produced a 60% improvement produced a 10% loss. And if you think that you're going to be able to reward the people who got a 60% improvement and take it away from the folks that got the 10% loss, based on this data, you're real short-sighted. Because you're going to end up with folks down here thinking, well, I'm going to tweak my system, and it's going to come back and bite you in subsequent years. Whether it's individuals or divisions, whatever. You know before you collect any data, you got 10 divisions, 10 people, whatever, that one of them will be in the top 10%, one of them will be in the bottom 10%, about half will be above average, and about half will be below average, and you know that before you collect any data. There's nothing you can do about it. What your job as a manager is to be able to reduce the variability of that and move it in the right direction. Your job as a manager isn't to play traffic cop and say, yep, that's better than that, that's better than that, that's better than that. A third grade dropout can tell you 60 is higher than 50. You're in business for, well, maybe a fourth grade dropout can not here. But you're in business for the future. Your decisions affect the future, and if you've got systems in place that automatically differentiate and say that this is above average and that's below average, or that there's sufficient difference here, you're going to end up paying for it. Maybe not this year, but you ain't going to be able to balance your books by expensing people. You got more than enough problems to deal with. So you need to understand that the valuable information that these two sources, these two voices, can give you. Obviously, the voice of the customer could look like that. In which case, you see market niches. The distribution doesn't have to be Gaussian. The other important thing to notice is that we're talking about more than just problem solving. If you take this distribution and the voice of the process, and you put it on there, and you put it right there, a lot of folks would say, well, what's the problem? There's no problem. Nothing is out of spec. No adverse variance to explain in a budget review. You were between the goalposts on whatever variable it is you're looking at. You've got reduced variability. Some managers will say, well, you got to be dumb to have a situation like that, do better than spec. What we're talking about is an opportunity for improvement, not necessarily problem solving. Problems, as I said, if you're over there, that's a problem. You're over here, you got no problems. Just proceed. There's very little incentive for someone, especially if you're buying it by the ton and selling it by the yard. You're going to roll it thin. You're going to park it on the lower end of the spec limit, and someone's going to buy it, but practically none of it is what they really want. If this middle is the target, and that's what it's going to get to the customer to brag, you're losing a lot of money just by feeling very happy that you don't have any problems. You're happy over a lack of a negative. You move it to there, that's a strong positive. And what I'm going to briefly go into, and I stress very briefly, is understanding how you can get higher quality for far less cost. And understanding the process of continuous improvement is key to that. For instance, I spoke about various paradigms. And I've got to apologize for this because I haven't erased the slide. But concentrate on the red area here. The premise is, or the current view is, that as long as you are within the specification limits, there is no loss, no economic loss. Everything's fine. As soon as you go outside of the spec limit, it's a step function view of loss. You incur all of the loss. You've got to either scrap it or rework it or whatever, but we'll call that the unit price. Such that this, anywhere in here, it's good. You go outside of that and you incur the loss. Well, again, we go back into the fact that this was a fairly commonly accepted model. Now, you could say, well, they're one-sided specifications, so you got to exceed this requirements, or you could say they're between it. It's the same premise. What typically is the way this model is viewed in the short term anyway is what really is the difference between that part there and that part there, a part just inside and a part just outside of the spec limits. If the foreman needs it for his quota, and that's what we as managers say is important, that part's going to get shipped because he doesn't see that much difference between just inside and just outside. The system ain't going to come down on him. The system's going to give him credit for meeting his schedule, so or meeting the profitability. Now, it's a little bit more complicated with the before tax. We look at internal hurdle rates, but that's why we have computers, and you just construct a scenario that'll get just inside, and everyone will be happy and they'll buy off on it. So, but it's the same kind of principle. There really isn't much difference between a little bit inside and a little bit outside, in the short term anyway. In the long term, if manufacturing or the production folks can explain to engineering that they really can't make it, then you get an engineering deviation. And as long as you got a good reason, especially if it's going to hold up production, you're going to get a deviation, and the system also is very accommodating. Now, again, I know nothing about the oil industry, petroleum industry, or whatever, but I would imagine there could be a lot of similarities. Another way of looking at it, a better way of looking at it, if you will, is recognizing that there is some best target, and you get that. Both of these are from the voice of the customer. That there's some best target at which you're going to have a minimum loss. You could be designing a process based on chemical conditions. You could be designing to stoichiometric conditions. Market research might have said that you've got a gold mine right there, and that's where you should target your process. And as you deviate from that target, theoretically and actually, you're going to increase. You're in an ever-increasing situation of loss. And it's not a step function. You just don't wait to get out there and then incur all of your loss. But the more you deviate from that target, that best value, the greater the loss is going to be. And and that, we find, is a far more realistic view of what actually happens in the world. Now, I'm going to superimpose the voice of the process on here. This is the voice of the customer. That's what we think the customer is willing to accept with that worldview. I'm going to put the voice of the process on there. And with this view, you've got no loss, no opportunity to reduce the variability. Everything is fine. Not fine, but you don't have any defects, no problems, no one screaming at you. So everyone's happy over lack of a negative. If you take the other view of the world, you're going to recognize that that same process, which is capable under one definition, now loses because you're producing parts that are away from there. They're not zero loss. They, in fact, are downstream losses. You're losing about 11% of your unit price. Now, I've come up with 11% because I've done the calculations, and I'm normalizing that to unit cost. The assumptions are only that this is quadratic, and every loss, there are different elasticity for every customer. Some will be very peaked, very sensitive to small changes, and others will be fairly forgiving. And that this is distributed normally. Now, we know before we start that there ain't nothing normal in this world, or there's no normal distribution in this world, but some things are close enough. But those are the only two assumptions that have to be made, and you can see that that new purple area is proportional to that loss. You've got about 11% opportunity for improvement. Now, one of the things that Dr. Deming says is that it's not quality at any price. If you've got 11%, you're losing 11%, and this is typically total system downstream costs, which makes it, unless you change your management system, it's very difficult to convince the folks at the mine mouth or at the drilling rig that they've got to improve their variability when it's someone else gonna reap the benefit. They've got cost centers, and they're going to maximize the use of those drill bits or whatever they do. So you wouldn't spend 20% on an 11% opportunity, but let's say you did spend up to 11% to reduce that variability, reblend the people, materials, methods, machines, and environment. And you came up with something like that. Instead of losing 11%, you're losing 1%. Now, here's a distribution that's plus or minus 10 standard deviations within the old spec limits. A very capable process by any one standard. What we typically see, even if you spent the money on the process, if you were visionary enough to recognize that, yeah, it would lose less for the total system if I spent money to reduce the variability to do better than spec. But what do we see many times? Many times we may have made the investment, you've got the super machinery, and you end up with repeatability that's like this, and you don't know what to do with it. Well, because of the profit center constraints, what you're going to do many times is set up the process so it starts out here and let the thing drift. You ain't never going to make any defects according to conventional wisdom, but you're going to let the thing drift back and forth, and then you're going to address the equipment or clean it or reinvest it or maintain it or whatever to reset it. We see that as a common method employed in industry in order to sub-optimize, and that's the correct term, the individual center's profit. What you end up when you do something like that, again, we see the uniform distribution creeping in a number of ways. You can do it by over-controlling. You can do it by setting up a process and letting it drift. Instead of losing 1%, you're losing 17 cents on the dollar. 17% of your output of your unit cost is lost. It's thrown out of the system. And if you don't understand this perspective of the world, and again, you let this stuff drift for the best of reasons. You don't recognize that there's an economic incentive for not only reducing variability, doing better than spec, but also keeping it centered. And it doesn't have to be centered, it has to be put on the target. The target could be asymmetric, but I'm not going to complicate it at this point in time. In the computer industry, there are ways to come up with completely uniform distribution by sorting, and you can lose 33% of your unit price, fat and happy, not recognizing that it's going out the window. You can even do better than that. As I said, you can lose 50% of your unit cost by camping it out on the lower spec limit, because superimpose that over there, most of the stuff is put in the high loss area. If you understand the sensitivities of what it's going to take to get your customers to brag and recognize that even though the specs are set up such and such a way that that's a high loss situation. Now, a lot of engineers will say, well, okay, I buy the premise that reducing variability, doing better than spec, makes some economic sense, and it does from a total systems view. What they many times think of is, well, the way I'm going to get that, and this is where these scratches come in, the way I'm going to get that is I'm going to reduce the spec. So the customer indeed sees less variability, a total span of customers, and they can use it. The less variability you see, the greater the usefulness of any kind of product typically to the customer is. They can take just about anything as long as it's consistent. You start giving them a lot of variability and their whole systems go crazy. So if consistency is the name of the game, I'll do it by tightening the spec. Well, what have you just done? You've been perhaps a more persnickety customer by estimating that's all they're going to take, but without addressing the voice of the process, the people, materials, methods, machines, and environment, you've just had to add, by reducing those spec limits, you just had to add inspection. That cost money. You've just incurred scrap and rework, or reblending and scrap, or whatever, you're burning it. And that also costs money. If you understand what Dr. Deming is saying, he's saying that if you spend the money on the process, understanding the complexities and the interactions between the people, materials, methods, machines, and environment, you're going to get that same, from the customer's viewpoint, that same lack of variability, that same consistency, but you're going to be able to do it at a far less cost. This is a case where and it's a viewpoint that you hopefully begin to understand, you can get higher quality at lower cost, not higher quality at higher cost. What I'm going to do is expand, as I said, I promised I would do, I'm going to further complicate the model. We spoke a bit about the voice of the customer. And we have a situation where as I see QFD, QFD stands for Quality Function Deployment. It is the latest quality buzzword this year. So if you don't know it, that's understandable. Unfortunately, a lot of folks subscribe to the Tool of the Month Club, and a few years ago it was where can I use a control chart, and last year it was where can I do a Taguchi experiment, and this year it's where can I do a QFD, Quality Function Deployment. And it's typically you folks that are making those observations, and you belong to the Tool of the Month Club, and the slogan of that club is, if the only tool I have is a hammer, it's surprising how many things start looking like a nail. And you understand that. So you've got this tool, and God, it's a panacea for everything, and that's all I got. It's a form of instant pudding. You're looking to you got all sorts of stuff to do, and all sorts of programs that are hitting you, and so you're gonna latch onto that tool and run with it. Well, quality function deployment can be a useful tool. It ain't a panacea. Hopefully you'll recognize that before we get done, that no one of these tools is a panacea. In fact, each one can add a different perspective. Here's quality function deployment, a way to be able to translate, operationally define that voice of the customer, help you be able to track the complexities throughout all elements of your business, such that you know from the shop to the top just what the equity people have in that, what you're required, and finally you're going to translate that into either specs or loss function or whatever. It's a way to deploy that voice of the customer and be able to end up with something that the individual process manager can use. Now we've got, as I said, I'm going to complicate it a little bit more. And we'll focus on the voice of the process, in which case you've got SPC, that form of SPC, statistical process control, looking at data over time, the predictableness of that voice of the process, extremely important in business. And as I said earlier, the job of any process manager is to identify the gap. What is that opportunity for improvement? It's not necessarily a problem. We know that there's an opportunity for improvement even though everything is within specification. No problem at all. You always have an opportunity to improve, and you're looking at that gap. Now the other, going to again complicate it a little more. Once you've looked at a gap, you got to now look at the map. And we're not going to come up with a rap to try and make sense of that. But you've got to, you have these are the results, the plan versus the actual, and you've got to ask the question, by what method? What are the internal customer and supplier relationships that resulted in this outcome, that gap particularly? And so you're concerned about just what that map looks like, what that process flow looks like. I'm going to digress just a little bit, and we'll quickly go through this. I had mentioned that we're all customers and suppliers, an interdependent network of customers and suppliers. And what I've done here is drawn the organization, that customer and supplier underground way of communicating, if you will, I've taken out all the hard lines, the organizational boundaries, either geographical or management and labor, or what you got, upstream operations and downstream operations, you got financial and you got support, something like that. And so I've taken out all the hard lines, and this is how the stuff actually gets done. And you can see there are customer-supplier relationships that go across the organization. Certainly they go up. You know, there's some very strong customer relationships going vertical. Unfortunately, many folks think their most important customer is their boss, and for good reasons. And some go kitty corner. What many folks have recognized a few years ago anyway, taking the cue from Max Weber and your organizational theory, what they've done is they tried to put hard lines in the organization such that you're going to increase the chances of control or talking to folks or whatever. So you'd say that's an organizational boundary, and within there I'm going to develop my function. And typically with Weber's theory you're going to look at finance and at engineering and manufacturing, whatever. And it was sort of a vertical orientation, and you aligned yourself that way. From a statistical viewpoint, you were looking to reduce the within-group variability, but anywhere you drew these hard lines, you're going to see that it might have reduced the within-group variability, but you placed the hard lines there, and it did nothing but penalize the between-group variability or the between-group communication. So a lot of managers recognize, gosh, it's hard for us to communicate this way, so what are we going to do? Reorganize. So what we're going to do is we're going to form project teams, and we're going to cut the hard lines that way, or make them dotted lines perhaps, and we're going to draw the hard lines that way because we recognize there are product and process flows, customer-supplier relationships that way. And lo and behold, it did increase the communication within the hard lines. But again, you drew the hard lines, you didn't understand the underlying customer-supplier relationships. You've optimized this way, but as we saw in the other one, you've compromised the between-group variability. So now you're looking for controllers for a various number of business groups that you just don't have a system to develop those strong people anymore within function. And it could be by geography. You could have North America, and you could have international or Europe or whatever, the chemicals or however you want to draw those hard lines. I would submit that unless you understand how the business actually gets done, and you do that by listening to your customers, and these are your customers right now, that you're going to sentence yourself to change or improvement by reorganizing. And it's an endless game. We see it many times. And the fact is that it only recognizes a very superficial view of organizational change, and that view is one of physical coercive. That is, if you report to me, I sure as hell can control you. And so we had a situation just last month where one stamping plant in one division had most of its business with assembly plants in another division. And they were having problem communicating, customer, supplier, whatever. What's the automatic solution? Assign that stamping plant to the other division. So now you report, and we're going to take care of that. Well, our recommendation, and they took the recommendation, was no way. There's no way you're going to reorganize to reassign that division, because you've got an opportunity to work out those between group, those actual communications that have to take place. The null solution of drawing a line around that, or buying out all your suppliers, or doing whatever you can to completely vertically and horizontally integrate is not feasible. The thought that just because you report to me means that we're gonna see eye to eye is absolutely ludicrous. It's a very shallow way of looking at managing enterprise. You've got to there are other levels of change that you got to understand, and I'll talk about them if we have time. So you've got an organization within your control. You also have suppliers, customers that are, quote, outside of your control. And in that case, a tool that's useful is shared objectives and interlocking actions. The extremely useful tool, and I'll get into a bit about that. I'm going to make it a little bit more complex, and this will be about as complex as it gets. Superimposed on this whole thing with a variety of tools, process, flow maps, the QFD, SPC, shared objectives, is a plan, do, check, act improvement cycle. It's a logical evolution from the scientific method. The Japanese, in fact, have called it the Deming cycle. Deming calls it Shewhart cycle. Some Japanese call it PDCA. Whatever you want to do, you've got to understand that is an integral method in this continuous improvement process. And what I found in trying to help management understand this is that instead of saying plan, do, check, act, I've tried to put some words around it. So I say develop a plan to improve the process, experiment with those proposed changes, got to verify the effectiveness of the experiment, and then if everything worked out all right, you've got to make permanent those verified improvements. Now, as much as management would nod their heads and say that, well, I understand that, I intuitively understand it, but what do you want me to do? A lot of folks are very linear thinkers, and so nothing against that, but a lot of times you have to create step by step. This is what I want you to do, and then we can execute. So I've broken down the 4 plan, do, check, act steps into 9 steps that I think anyway, and I found that virtually every manager can identify with. And I'm going to quickly go through them. Step 1, obviously, is to identify the opportunity for improvement. What's the gap? You got your estimate of what the customer wants. You got your estimate of what the process is giving you. What's the gap? Here's a particular example where you have a timing gap. You have a group of engineers getting together, and trying to estimate that voice of the customer. The voice of the customer, if you look at it, this is the scales backwards a bit, but you have the months from concept to commercialization, concept to job one, if you will, in the auto industry, concept to commercialization perhaps everywhere else, such that if the engineers got together and said, if we could develop an automobile from imagination to getting that thing out on the road in 48 months, that's going to be great. We feel that if you balance the timeliness with the dated with the job involved in taking an automobile there, that 48 months would be good. In fact, and some of that's guided, well, the competition will be able to do that and perhaps could even get better. Well, that same group of people has to then ask the question, okay, well, that's the druther. That's our estimate of what it should be. What is our estimate of what the process actually is delivered? Well, you take a look at the voice of the process, and program after program, year after year, the typical amount of time it took to develop a new automobile was about 70 months. Sometime the best they were able to do it, again, a brand new one, you can come up with modifications in a lot less time. The best you could do was about 66 months, and sometimes, I was kind here, we cut it off. Well, there were some outliers way up there, depending on how you define concept. This is an important piece of information for managers, because it says that even though this is a great aspiration, and you see a lot of folks in the sales division signing up year after year after year saying, yep, 50% increase in sales this year, and ain't no one going to tell you, no, I can't do it. It's a can-do attitude, I'm going to do it. And they spend the rest of the year coming up with real good reasons to explain why they didn't. Especially if you've got this kind of situation, that comparing the voice of the process with the voice of the customer says that with the existing blending of people, materials, methods, machines, and environment, there is no way in hell that this blending of process is going to get you anywhere near there. It's beyond the realm of possibility of the existing system, and trying to work harder with the same system is going to get you nowhere except frustration. If the voice of the process, on the other hand, said that was the variability of the system, then at least you'd know someone was able to do it then. That's not a guarantee that you're going to be able to deliver that 48 months, because you still have to figure out a way to move that average, if that's what you meant by that. Some will be more and some will be less. Again, you've got to operationally define what you mean by that target. But that's a different signal. But unless you compare the actuals over time, looking at what the process actually delivered and what it is that you think the customer wants, you really won't be able to make an intelligent decision. And your people will recognize that. I've got other examples, but I won't take the time of matching the voice of the customer with the voice of the process. Step 2, document the present process. What's the process map? Here's an example of Inland Division of General Motors' budget process. Obviously unreadable, but it's purposely so because it's an extremely complex process. It took 191 days from the issuing the budget letter to the reconciliation when it was approved. 191 days going through approval after approval, delay after delay, people diddling around with this and that and whatever, and extremely complex. Very important, extremely important to get the team together on this, because everyone has a different perspective of what it is they're trying to manage. For instance, I'd mentioned the different tools. You many times have the situation where you ask one person, especially in administrative situations, you have a perspective of what it is that budget process should be. Absolutely, I know what goes on there. And so you ask you, or you use one tool, or ask one person. Yeah, I've seen those 3 circles before. I know exactly what that budget process is. You ask your people on the floor, the people who are trying to do it, and you're going to get a different perspective. You ask a different question, ask a different person, you're going to get a different answer. That's not necessarily bad. It's going to help you understand what you're managing a little bit better. You use a different tool, and you're going to get still another perspective, another answer. The written procedure will be different from what you think is happening and what your people think are happening, especially in administrative situations. I want to submit that you are never going to know what the real world looks like. You ask a different question, you get a different answer. And you always are going to have incomplete information. But the more perspectives that you've got on what you're dealing with, the more tools you use for different purposes, the better it is you're going to be able to understand what's behind that curtain. And if you think that that you're just going to be able to do it alone and say, yep, by experience, I know absolutely those are 3 circles, you certainly won't be making the contribution you think you're making to your company. So these are team tools. Now, after you're trying to understand what the present process is, step 3 is to create a vision of the improved process. And it's a trade-off, but on complicated processes, you need to do the visioning afterwards, mainly because you have no idea of the inefficiencies you've got in the current process. And if you do it beforehand, your vision more than likely is going to incorporate some of the inefficiencies that you got, and you don't know they exist, and so your vision ain't going to be as good as what it could be if you'd done it afterwards. Now, you obviously have the constraints that you're going to try and be free-thinking and whatever, but do the visioning afterwards. Here's a view of the vision. And the vision is, how are you going to reduce the gap? How am I going to rearrange these resources in order to reduce that gap? And they were able to simplify the process, recognize once you get the existing thing on there, good Lord, you can cross off whole steps and ask why we're doing that, why are we checking this or whatever. And they took out 1 whole quarter, 3 months out of that budget process. It still takes about 100 days, but that's certainly a step in the right direction. Again, getting the team of folks together to understand that, especially useful in these administrative processes. Okay, so you've got the vision. The vision is to try to reduce that gap. Step 4 is really to define the scope of the improvement effort. Now, and part of that is who's on the team. You can't do this step in scoping it out until you have identified who your customers and suppliers are. Have you done the process flow? Those customers and suppliers should be on your team. How many times have we convened a team and the right people aren't there? You didn't use that thought process of getting the right folks in the room. Who's going to be the team leader, the responsibilities, the resources, people, materials, methods, machines, and environment? You can't do any of this until you've logically done those first few steps. By what method? You really have to question the methods you use in everything you do. And what's the projected impact on quality, cost, and timing? Now, I picked those 3 because those are the 3 superordinate set of objectives that both Ford and General Motors now think is important: quality, cost, and timing. So everything we do has to map back up into that. And here's where you get into the shared objectives and interlocking actions. And this is a Ford example, but it shows you that in complex situations, you need to be able to recognize these interlocking actions. Now, this thing couldn't be constructed until you again have done the process flow diagram, because all this is a matrix view of the players, the customers and suppliers, and each of these nodes is customer-supplier relationships. But you blow this up, these interlocking actions are the who, what, when, where, and why. How are you going to be able to reduce that gap? In this particular situation, the Order Processing Center of Ford was tasked with reducing the number of misbilled vehicle claims. And they would do that by setting up a huge phone network to talk to the dealers. And a dealer would have a misbilled vehicle claim, and they would call into the Order Processing Center and sort it out and then proceed. Well, when the number of misbilled vehicle claims got too high, there was a campaign, a lot of special action, going to beat the dealers down and really lower those number of misbilled vehicle claims. And that's what the Order Processing Center was primarily paid to do. Unbeknownst to the Order Processing Center, and they would feel very happy that the campaign worked and the number of claims would go down, unbeknownst to them, Ford Parts and Services Division was experiencing an unexplained rash of zero-mileage warranty claims. Well, you really couldn't explain that. And they then would beat on the dealers for zero-mileage warranty, and they would feel very happy that that campaign had worked. And unbeknownst to the 2 previous parties, the Assembly Division was experiencing transportation damage claims. So until someone recognized they were part of a system and feeling very great, people were promoted for putting out these fires. And a fire was too high a claim rate, you get that down, you're a hero and you go on somewhere else. And you had a continual feeding off of fires and really a career generator. So you have, some people can identify with that. So until the team got together, some enterprising process manager recognized who were the customers and who were the suppliers, including the dealers, got together to operationally define what a misbuilt vehicle was in the first place, what zero mileage warranty was, and what transportation damage, and I forget the other claim. But you could put it in any pigeonhole you wanted to, really. And you don't have to pick on the dealers. You go to the shop floor, and if you're just managing outcomes, you got foremen who will give you the outcomes you want, and for the best of reasons. For the best of reasons. I'm not saying they're trying to fool you or anything, but they know they have more important things to do. So if rework or blending is too high, nothing changes, but they bin it another way, and everyone's happy. But nothing really improves. So until the team gets together to operationally define that, nothing really got done. And what you recognized here, that Ford Parts and Services could not do anything until it got input from Dealer Affairs and Ford of Canada. Those are the interlocking actions. There's not one, and this is needed in a lot of cultures, because when push comes to shove at the end of the year, if your department manager hasn't met his objectives, it ain't in his best interest to have his people out helping other folks. You're going to pull them back, and you're going to shore up your objectives, because your career depends on meeting your objectives, not Sam, your best friends. You might be best friends privately, but you know all bets are off when it comes to meeting your objectives. So you got a system that sub-optimizes, everyone feeling real happy about meeting their objectives, and in actuality, the whole process costing far more and being far more wasteful than it has to be. So this is the framework for the plan, executing who's going to do what, when, where, and why. Obviously, step 5 is then you've got to pilot the proposed changes. You've got the plan, and I emphasized 4 steps in the plan stage because my perception is that American industry doesn't do a good enough job in planning. And step 5 is pilot the proposed changes. I didn't say experiment, at least up in the top here, because folks have a phobia against experimentation. That's black art. But I do say it here. So you've got to experiment on a small scale. You can't put the company at risk. You're not going to bet the farm on some of these major changes. With customers, which is hardly ever done, you absolutely need the input of customers. And over time, many times you have a brilliant engineering change and you put it in, you run it for an hour or a day or 5 parts or whatever, no defects, that's a fix, install that, and you end up reinventing and time over time. Look for positive or negative synergy, extremely important. Test one at a time or many at a time. They're both viable ways to look at it. If you use many, you can use a factorial approach, Taguchi, in some situations, or accelerated designs. You've got a whole wide range of tools you could use if you understand the complexities of the process. Now, I spoke about interaction, and what we're looking for is the best blending. You're looking for an outcome that the customer is going to brag about. And if you independently pick the best equipment and you got a negative interaction with the people because they don't know how to operate it, you haven't trained them in figuring out how to maintain it, the outcome because of this negative interaction isn't going to be what you expected. I used, although that's an old example, but the Philadelphia 76ers are tired of explaining to the city of Philadelphia that we owe you one. The best raw talent a few years ago that money could buy, and yet you were looking for a team effort. The individual expertise blanches or pales compared to the synergy you can get with a team of individuals. All of your John Wayne's sharpshooting superstars ain't going to be able to hold a candle to a team of folks who can combine their resources and really excel. And that's the obligation we have as managers, to try and construct systems that are going to blend the individual expertise that helps us. Again, I get to pride of workmanship, the pride of ownership through the pride of workmanship. We've got to come up with systems that certainly fosters and continues to grow that individual excellence, but don't kid yourself. You also have to have systems that are going to grow that team spirit. And his traditional gunslingers and superstars, if we persist in that, you'll be out of business before you know it. The opportunities that you need to be truly competitive in this day and age are far greater than any one company can muster. And you don't necessarily have to experiment, when you talk experimentation, on materials or equipment. This processing equipment is better than that. You can experiment on methods. Here's we proposed 2 different design ways to process and implement a design, and compared those with one another. So you can experiment with people, materials, methods, machines, or environment, and you look for that synergy. That's what management's paid to do, to get more out of a group of individuals than they could as individuals. You don't pay a manager to be an engineer. Sometimes you might. That's not what you should pay them for, though. You got engineers to be engineers. Step 6. Once you've done the experiment, the pilot, what you're supposed to do is to see if the improvement occurred. You piloted the thing to see if that gap was reduced. Here's a particular situation where we have the voice of the customer. It's a negative characteristic. We're shipping parts for knockdown kits of automobiles from Europe to Venezuela. And the intent was that you wouldn't have any missing parts. You'd have a complete kit when you got there. But lo and behold, there were from 2 to 6 missing parts, and they couldn't build the autos. Now, at most 6 kits a day doesn't sound too bad here, but in a Venezuelan market, that was noticeable. So what you've got to do is you do the pilot. That's the voice of the process before the pilot. They made some changes, piloted it, and the voice of the process after the pilot showed that, yep, the gap was reduced. It still isn't 0, but the gap's reduced. And that verified the fact that the improvement did occur. Next thing you got to do is turn your hat around and say, well, can I run it as a business? It worked at pilot. Does it scale up? Or it worked once. Can I maintain those resources at that particular level? Can I run a business at that level? A blending of people, materials, methods, machines, and environment. In this case, you've got to go to your process feedback loop and see, is it stable? Are the outcomes stable? There'll be variation, but is it predictable? In this particular case, we saw that that over a 2-month period, and in that 2 months was not based on statistical reasons, it was based on letting the people, materials, methods, machines, and environment, the various shifts or whatever, vary to see what, as well as the length that was indicative of the length of the pipeline, so that we could see whether it was predictable. It says it was. So what you do, that was verification that the manager can run the business that way. Step 8 is you got to try and institutionalize that new mix of resources. The people, materials, methods, machines, and environment in one combination worked in the pilot. They were predictable over the pilot. Now we've got to make sure that those are put in place. Now here's where I'm going to complicate this, and that is that I've waited till now because it just, even though it's a simple thing, I've found that it's a lot better introduced now. I look at process as 3 relative levels. First of all, a core level. Every one of us manages a core level process. You can go in greater detail to micro level, and you can expand it to macro level. The chairman of the board of Exxon manages a core level process, Exxon. He obviously can go to a micro level, a lot more detail, and he also can go to the macro level, Exxon's place within the United States, within the world. Every one of you manage a core level, and it's all relative, such that if you made a change if you were operating at the core level, and this you'll recognize as the shared objectives and interlocking actions, if you made a change here, let's say you had some agreements in changing an accounts receivable system, you then might want to go to the micro level because to really solidify that, you might have to change a data entry or an invoice handling kind of system at the micro level, and you might want to pump out to another divisional level and make sure that all accounts receivable systems in the company operate this way. Or it may be the macro level is the whole financial management system in a particular division. All I'm saying is that until you recognize those interdependencies, and that's going to take time because it's not obvious, these relationships are not obvious with your state of understanding of your business. And I could say that with a large degree of confidence. You need to understand how the business operates and what those microtransactions are and you begin to build this the more and more you get the team together. I have no doubt that every one of you has a perspective of what those relationships are, but I would submit to you that there as many people as you've got in here, that's how many perspectives you have of what's actually happening. Okay, so you've tried to institutionalize that. What you're going to do now is, step 9 is to repeat the steps on the most promising level. You're going to try to if you could cycle through on the core level, or you could spin off to the micro level or back to the macro level and go through the 9 steps of the Plan, Do, Check, Act again. Look at the gap, the map, and et cetera. Sometimes a lot of folks say that, well, once I've got one process or one problem licked or one process capable, I'm going to let that stand and go on to another process. If you understand the loss function, it may be better to work on your strengths and get them reduce the variability even more and let fly the supposedly things gone wrong or your weaknesses. And again, that might fly in the face of what you think is good management. When Ford brought out the Taurus Sable, a number of the traditional auto companies, when they were looking at things gone wrong, that was a conventional way of measuring quality in the auto industry, were snickering because the things gone wrong on the Taurus Sable exceeded the car it replaced. But what they didn't know was that we had done the market research to figure out the things gone right, what was important to the customer. And the things gone right overshadowed the things gone wrong, and if you really were right on with the things gone right, that really was the differentiator. So by traditional rules, it didn't look too good. By a new perspective, we found that's what really sells automobiles, getting it right. Now, obviously, there are a number of tools, and this is unreadable, but it from brainstorming to visioning to a number of other kinds of tools, and some are applicable to some steps and some are not in others. And obviously the point I'm making here is there is no universal tool that's going to get you the right answer all of the time, or not even part of the time. You've got to use that blending of tools. Now, what I began with was this pride of ownership through pride of workmanship, and I alluded to it a number of times, at least the need to cooperate. I want to close by telling a story that Bill Ouchi told. He had the opportunity to address a United States Trade Association meeting, and it was in the wintertime, so it was in Miami. I have a strange, did I tell this earlier? Okay, the earlier session. I'm sorry, sometimes I have a sense of deja vu here. In any event, that trade association meeting, that trade association was comprised of 200 to 300 U.S. companies, large ones, small ones, OEs, suppliers, whatever. And predictably, because it was in the wintertime, it was held in a country club outside of Miami. And as I said, a 3-day meeting. In the morning of the first day, they had Ouchi come in and speak for 4 hours and 1 minute. According to IRS constraints, that qualifies them for a seminar or a trade association meeting for tax purposes. And in the afternoon, they had golf scheduled. And in the morning of the second day, they had a technical session all morning, 4 hours and 1 minute, and then they had deep-sea fishing scheduled. And in the morning of the third day, they had another technical session all morning, and then they had tennis scheduled. Well, Ouchi gets up there the morning of the first day, and And he says, you know, I've got nothing against golf or tennis or fishing. I don't doubt the networking and the deals you can cut on the golf course and all of the camaraderie you can develop. He said, but I want you to think about something as you tee up this afternoon. He had the opportunity to talk with their direct competitors from Japan more than a few months previous to that. And their trade association had about the same size, 200 to 300 companies, large ones, small ones, whatever. Their trade association meeting started at 7 in the morning, went to 8 at night, 5 days a week for 3 months straight. So that they, as an industry, could duke out their problems, and they've got the same kinds of problems and differences that our industries do. It's a mistake to think that everything is uniform over there. So they could duke out their problems and differences so that they could approach their government with one voice, not 200 to 300 separate voices running to try and get to the trough at the same time. So that they, as a nation, could combine the resources of industry, the resources of government, academia, even agriculture, the various sectors involved, public, private sectors, so that they could then proceed to focus those resources on the particular market segment that they needed to focus on. And Uchi says, you know, who do you think is going to be ahead in 5 years? Well, if you honestly answer the question, it ain't going to be the folks in Miami. And in fact, it wasn't. But what those people have recognized is that with all this talk about competition, what they've recognized is that in order to compete, you've got to first learn to cooperate. That the problem, the opportunities, the resources needed to focus on this international economy are far greater than any one company can bring to muster. General Motors isn't big enough, you aren't big enough to do it alone. You've got customers and suppliers that you have to recognize your interrelationships with, and you can't do it by brute force. You've got to be able to cooperate. Superstars ain't going to get you where you think you're going. Again, if there are two, every human being has two equally compelling needs as a human being. The one is to be able to take pride in your work, to feel important as an individual, and the other is to feel a need of belonging to society, belonging to a team, a family. Those are equally compelling needs. We in the United States have developed the strength of the individual. John Wayne, that's the way we do it, the individual brilliance. Japan, on the other hand, has built the same human being and strengthened and fostered the strength of the family, of society, much to the detriment of the individual. We've fostered the individual much to the detriment of the team. If we're going to get ahead, we're going to have to be able, as I said earlier, to create systems that are going to be able to use and tap that individual brilliance, but recognize that there ain't none of you who do it alone. In order to compete, you've got to learn to cooperate. Thank you.